Okay, students, let us start. Can you hear me all? Can you send? Yeah, okay. So Mithun has signaled that you can all hear me. So I will now share the screen. Okay, so we will start. So I hope all of you are doing fine, staying healthy and safe at home. So please maintain the directions given by the government of India. Please try to stay at home as much as possible unless there is an extreme emergency. So we have been talking about media bias for the last few lectures, and today we will do the third and the final paper in this segment. So this paper was published in ICWSM 2019, and this was by a group from USC and UIUC. And I am very thankful to my friend Emilio Ferrara, who has generously permitted me to use their slides for this lecture. So thank you very much, Emilio, for this generous help, especially at these trying times. So we will continue with their slides. And today we will be talking about specifically a special type of social identities or online social identities called trolls, and more specifically political trolls. So, and we will see how language use can actually help us characterize political trolls. So before we go into the details, let's have a few statistics. So this is something that we have looked at into the previous paper also. So it's like 2/3 of the Americans getting their news from social media. And I think you can expand it across other geographies also, like with the smartphone and internet penetration in many other countries. I would imagine that the statistics would not differ much. So while this is an important point to note, what is more important is that 13% of the posts by Facebook users who report their political ideology are political news. So if you're expressing your political ideology, in 13% of the cases, you are expressing it by sharing some political news. So that's the idea. So if I have a political ideology, rather than going upfront and talking about the ideology, a secondary approach that I would take is to share political news which kind of subscribes to my political ideology. And 13% of the Facebook posts are like that. So, but then what is the problem? What is the issue with this? So the issue with this is the following, that many of these posts may not be even generated by humans. Okay. So this is a important point, that certain posts among these 13% might not be generated by humans. And why do you think is this important? Can someone quickly message me on the chat and tell some of the opinions? Why do you think that that noticing this is important in the first place? We can talk about repercussions later, but why is it in the first place important to notice this. Can someone quickly tell me over chat? What do you think? No ideas? Yeah, so there are a few points that people are pointing out. Like Punajoy says that bots might manipulate the content. True. They can, so these humans, these non-human entities, so Aditya is saying that non-human entities can, use bots to, so you can use these non-human entities to bias public. True, we will see some of these. And political parties with money might hire agencies to influence common public. So very true. These are some of the points that you have very rightly remarked. And this is what is sometimes called social bots, or trolls in this particular paper would refer to social bots. And these are user accounts whose sole purpose is to sow conflict. Okay? So you want to actually seed in conflict in various different ways. And that is the one particular motto of trolls. So basically, we have to interpret it in this way. Trolls are a special type of social bots, which are user accounts that have a sole purpose to sow conflict. Okay? So this is how you interpret it. There might be some good social bots also, but in the context of this paper, we will restrict our definitions to those social bots whose specific motive is just to sow conflict in the online social platform. And this kind of social bots are typically known as trolls. So it has been actually conjectured, and I think you guys have also read a lot of newspaper articles related to this, that such trolls have attempted to manipulate the 2016 US presidential elections by different means, by injecting false tweets in social media, by placing up fake news that would support or be conspiring against certain candidates. So this is something that has been conjectured a lot, and in fact there are a lot of works, including one of our works that we published in CSCW 2016, which talks about a special type of elements on social media called sock puppets. Okay, so these are, so as the name suggests, these are like puppets, and they only do like things that actually help spread the message that their followees are actually trying to spread. Okay, so this is an important actually weapon for various presidential campaigners to, sow conflict in the social media, which, as we know, can have strong offline repercussions. And as people have rightly conjectured, that the US presidential elections probably have been influenced by these kind of injections, false injections. So, in fact, there is a report by Gerber and Zawiska who actually said that, who actually showed that, like, there were allegedly funded organizations by the Russian government to influence conversations about political issues, okay, with the goal of creating discord and hate among different groups. So people, as one of you have rightly pointed out, that you can actually have paid agencies who can promote trolls for you and sow these conflicts and inject false news hatred among people in the online platform. Okay. So there are evidences to support this observation. And actually, deception in the US presidential politics have become a pervasive phenomena for the last several decades. Actually, this has been noted in another work by Bornstein in 2016. So this is all around, you see, these studies have all been done around the presidential election time. So, so deception has been used as a tool for quite some time in order to, change the game. So the question now, as we have always asked, is how do we operationalize deception? Okay? So this is a question that we have to answer even before we proceed to do any further study. Okay, so how do we have a computational definition or operationalize the definition of deception? Any ideas? Any thoughts on this? What do you commonly relate deception to? The word deception to. Any thoughts? Okay, so yeah, there is somebody answering. So Manasvi says that false impressions. Yes, false impressions is one of the, of course, dimensions. So let us try to formalize it a little better. So generally entails messages and information knowingly transmitted to create a false conclusion. Okay, so it is knowingly done. So it's actually creating false impressions, as Manasvi say, but then it is done intentionally. So deceptive information includes, but is not limited to, lies, fake news, which we have already studied, rumors, which we have already studied, but disseminated to change people's, belief. So you try to change the cognition or the belief of the common mass. This is also sometimes called cognitive hacking. So you hack not, passwords, but you hack the cognition of humans. And in fact, cognitive hacking has been shown to be one of the strongest modes of warfare in current times. So you change the kind of belief in the common mass by showing them, false information such as fake news, rumors, etc., repeatedly over time and from multiple sources. Okay, so this is another slide which we have already talked about earlier also. So, so we have this truth biased nature. So basically, you are made to believe, as this cartoon suggests, that you are right and everyone else is like a stupid. So, and you keep on continuously getting immersed into this echo chamber and confirmation bias. So you see things what you like to see, and the system suggests you more things that you like to see, and you seclude yourself in this world of likings only. So this is happening like at a wildfire, like a wildfire now, and unfortunately there are very less contention mechanisms. And I think, like, you have already seen that this is also happening with the coronavirus pandemic situation that is going on now. So people are saying, especially social scientists and people working in computational social science, is that this is one of the largest social infodemic. So by the word infodemic, what they mean is that, people have started abusing others stating that they are the reasons for the like rise and spread of this pandemic. Okay, and people are actually assaulted, people are actually hated. So this is a new hate speech paradigm that has opened up actually. So we have talked about hate speech in our earlier classes. Now this is a new hate speech paradigm that have come up into existence now. So there is a lot of xenophobia and things like that that is active on the online social media. If you look a little bit, in fact, there is a MIT Technology Review article which summarizes this very nicely. And then the second point is also, I think we have already talked about earlier, is that the accuracy of human detection of deception and fake. And when we are studying fake news, we have seen this already. It's like just a little better than chance. I guess you remember that our chances of identifying truth from falsity through our perceptive capacities is like somewhere between 53 to 57%, which is just little above what you can imagine or hope by chance. So the hypothesis that this paper actually tries to posit is as follows. So the authors say that deception can be identified through certain markers of deceptive language. Okay. So, and this might be helpful in identifying deceptive trolls, and the authors then go further to compare these deceptive trolls with tweets that come from legitimate users during the same time frame. Okay? So you have a set of trolls and you have a set of legitimate users. You try to find out certain linguistic markers that are indicative of deception and that are well known in the literature to measure the extent of the presence of such markers in the tweets made by trolls compared to legitimate users. So this is the central idea of the paper. So the authors actually for this purpose study the language used by Russian trolls during Russia's campaign to interfere in the 2016 US presidential election. Okay, so the authors use the language markers that are indicative of deception and apply them to the tweets posted by the Russian trolls and are known to have interfered into the 2016 presidential election. So that's what they target for. The specific research questions that they put forward are as follows. How do trolls insert themselves in political discussions on Twitter? What topics do they discuss? So these are some of the things that the authors will go on and study. What deceptive linguistic cues can you actually identify or measure? Okay? And can these deceptive linguistic cues help us automatically detect troll accounts? Okay? So given these deceptive markers, first of all, we have to see whether these deceptive markers actually have any role in distinguishing the tweets posted by trolls compared to tweets posted by normal users, legitimate users. And if they do, can these markers be successfully used in order to detect the troll accounts? I mean, compared to the legitimate accounts. So of course, in order to launch such a study, the first thing that you need is data collection. How do you even opt out for collecting data? So this is the strategy that the authors used. So they used a list of around 2,700 Russian troll accounts, which were compiled and released by the US Congress. So these are, known troll accounts, known Russian troll accounts that were compiled by the US Congress and released for mass consumption. Okay. Now, the issue here is that although you have these trolls, I told you that Twitter has this very strict policy of, suspending users based on their hateful behavior, hateful and abusive behavior. So therefore, even if you have, access to this list, it would not be very easy to actually get the tweets posted or the activities done by these trolls because of the suspension done by the Twitter. Okay, so therefore the authors use something called a Crimson Hexagon toolkit, which is a social media analytic platform that provides paid data stream access. Okay, so they actually paid money to Crimson Hexagon to get all the tweets related to these 2700 trolls. Okay, and this tool actually allowed the authors to collect the tweets and the retweets produced by the trolls, and which were many of which were actually subsequently deleted in 2016, okay, because of the strict policy norms of Twitter. So thanks to this particular platform that the authors were able to gather all the tweets required for their analysis. Now, this is a summary of the descriptive statistics of the troll dataset. So the unique Russian trolls that they had in the data was 1,148, okay, for which they could collect the Twitter data. The tweets is quite large, so around 12 lakhs, 1.2 million. Retweets by trolls and original tweets by trolls together make up the total tweets. So that tweets that you see in the second row is divided into retweets and original tweets. And then trolls who posted original tweets, those who posted at least one original tweet, their count is 1,032. So there were quite a few trolls who actually did not post anything, but they were only retweeting. Okay. So they did not post any tweet by themselves, but were only retweeting the post that the other trolls tweeted. Now the question is non-trolls. How do you collect a comparable legitimate data set, okay, which the authors call non-trolls? Now for this, they use two strategies. In the first strategy, they used a list of hashtags and keywords that relate to the US presidential election. Okay, so this list actually includes similar number of hashtags and keywords, roughly similar number of hashtags and keywords associated with every major presidential candidate. So there were 23 terms, and this is the distribution. 5 terms were referring to the Republican Party nominee. These were Donald Trump, Trump 2016, never Hillary, Trump Pence, etc. 4 Trumps from the Democratic Party nominee Hillary Clinton. So these were Hillary Clinton, never Trump, etc. And several other terms related to the debates that they had, debates. So there is this idea of having debates before the elections. So terms were gathered from those debates. There is a question. So there is a question by Purnojoy that are the creation dates of all the trolls nearly at the same time? Is there any data in the paper? Yes. So it's all around 2016. So they were concentrating mostly around end of 2015 to all around 2016. So this list itself that I have shown you that was released by US Congress is all around 2016. Okay, and out of which they could only get access to around 1150, all of which were created close to the I mean, in and around the year 2016. So, but in order to have a very fair representation, so they had also few keywords from two other third-party candidates, like the Libertarian Party nominee Gary Johnson, that had 1 term, and Green Party nominee Jill Stein, that had 2 terms. Okay, so in terms, they started collecting data from Twitter, streaming data from Twitter. This was the first strategy. The second strategy was, so once they have collected all the tweets that they found from strategy 1, they looked into the user accounts of these tweets. And now they went to the user profile, okay, and collected all the tweets posted by those users, but not containing any of the 23 keywords, okay? So not containing the same key terms that is mentioned above, okay? So they go back to the user profile for all the tweets that they have collected through strategy 1, and now they actually, scrape the profile of the user to get more tweets. But they ensured that these tweets do not contain those 23 terms, okay? Because that then they have already collected. Okay, so that's why they do not want to recollect the same things, that because that would be data duplication. And they also ensured that they collect data from only those users. So we have 10 more minutes. So let's use this time more meaningfully. If you have some questions, you can shoot now. So collect tweets from the same users that, they do this, but they exclude all the users who have retweeted at least 1 troll. So that means these users are not legitimate. That's their hypothesis. So if you are actually retweeting trolls, then you are not considered to be legitimate, So that's the author's hypothesis, which is kind of, I would say, a sensible hypothesis, because then you are in some way subscribing the troll, the idea or the tweet posted by the troll. So these are the 2 mechanisms for that they use to collect the non-trolls. Any questions so far? About the data collection? Okay, so in this way, they collected around 1.1 million non-trolls, okay, and a huge number of tweets. So these were the tweets collected by the strategy 1 plus strategy 2, okay, and this non-trolls, the tweets by non-trolls are again divided into retweets by non-trolls and original tweets by non-trolls. Okay? So you have this division. And there were around 140,000 non-trolls who actually posted original tweets. So many of them are actually retweeting, so which is like a predominant behavior in general Twitter platform. Okay? Most people would tend to retweet than post. Okay, so so this is the descriptive statistics of the non-troll data set. Right? So now we have one set of data for the trolls and one set of data for the non-trolls. So do you have any observation from these 2 descriptive statistics? What is the single point observation that one could make? Quickly. Non-trolls retweet more. Anything else? Mridul says that non-trolls repeat more. Any other observation, any other gross data level observation which might have repercussions to any machine learning model that you develop? Yes, imbalanced data set. So that is the most important point. So as Punojoy says correctly, that you have a much larger number of non-trolls, both in terms of tweets as well as in terms of number of users compared to that of trolls. Much larger number. And so when you do simple statistical analysis of characterization, it's still fine, but then one has to think how to actually devise machine learning models for such unbalanced data sets. Okay, and we will see that maybe in the later class. So now, as I said, that there is already quite a bit of literature to identify cues for deceptive language. Okay. So the first theory that actually talks about identification of deceptive language is called interpersonal deceptive theory, or IDT. So this was proposed by Buller and Bourgon in 1996. So what they stated is that deceivers tend to use less structured and more evasive kind of language. So the structure in their language is like very, fluidic. So basically it lacks structure. It lacks good coherent linguistic structure. Okay. So a well-framed sentence will have a nice distribution of part of speech, etc., which these kind of deceptive users rarely use. Okay? So this is what is the theory that is actually presented by the IDT. Okay? The next is the verbal immediacy theory. So this was proposed to infer people's attitude or affect. Okay, so basically immediacy refers to, like, the psychological sense of closeness or distance. Okay, so if something is close to you or if something is distant from you. Okay, so you have verbal and non-verbal cues to create a psychological sense of closeness or distance. Okay, and it has been shown that the deceptive markers actually adhere a lot to the verbal immediacy theory, and there is like less closeness in this type of language. Okay, then there is this criteria-based content analysis, or CBCA. Okay, this was first developed to determine the credibility of child witnesses' testimonies in trials for sexual offenses. So basically, children were asked to give testimonies, okay, about whether they were sexually abused or not. Now, you might tell the truth, you might not tell the truth. Now, how do you identify whether the witness that the child produces is credible or not? Okay, this idea has also been used recently to assess testimonies by adults. Okay, so this was proposed by Raskin and Esplin in 1991. Okay, so the idea is very simple. The statement derived from memory of an actual experience in content and quality is different from a statement based on fantasy. So this is something that we have already read also in our fake news literature. Okay, so what it again states is that if you are recollecting something from an actual experience, then that would be very different in content and quality than from something that you are recollecting from fantasy. And then there is this reality monitoring. So it holds that a truthful memory differs in quality from remembering made up from an event. This is also something that we have actually discussed in our previous lecture on fake news. So in the next class, we will see how these measures can be used to actually characterize trolls from non-trolls. So we have less than a minute left. We will stop here, and in tomorrow's class, we will proceed further. Okay, guys, can you hear me? Can someone chat and reply? Okay, so you can hear me. So I'll now share the screen. Okay, so we start. So last day we were looking into the analysis of political trolls, and we saw how the authors actually collected troll data as well as a set of legitimate tweets and their user accounts, which they call the non-troll data. And then we have also seen like there could be various linguistic markers of deception that one can possibly use to characterize trolls from non-trolls. So some of them we have already talked last day. I'll just quickly review. So the first one of this was the interpersonal deceptive theory, or IDT, which says that deceivers would typically tend to use less structured language. Then there was verbal immediacy theory, which says that there will be some notion of closeness or distance associated with the um, text. Then there was criteria-based content analysis, which said that, which holds that a statement derived from the memory of an actual experience would be very different in content and quality from something which is actually derived from a fantasy. And then there was this reality monitoring idea, which we have also looked into earlier in the context of fake news. That is, truthful memory differs in quality from remembering a made-up event or a fantasy event. So in summary, the authors actually build a set of 49 linguistic cues, which could be potential markers of deceptive language. And they calibrate this into 8 different broad categories, like uncertainty, words such as possibly, may, etc., which indicates speculation. Non-immediacy, that is use of passive voice and avoiding self-reference, okay, increasing group reference. Specificity, use of words like because, effect, hence, etc. Information complexity, which is typically measured in terms of the number of words, the length of the words, the length of the sentence, then the amount of punctuation used, etc. Then there is information quality, which is the number of words, again, use of various part of speech like verbs, adverbs, nouns, and prepositions. Persuasion, like giving examples, citing examples of different, could be facts, fantasies, sharing URLs, hashtags, etc. Then using morality related keywords like care and harm, fairness and cheating, loyalty and betrayal, authority and subversion, purity and degradation, and things like that. So words related to this kind of concepts. And then you also have the metadata along with you in the data set, like the number of followers, number of followees, total tweet count, user status count, and number of retweets, etc., etc. So they categorize these 49 linguistic cues into these 8 different broad paradigms. And we will look into a little bit more detail of each of these paradigms. So uncertainty. So the authors try to estimate uncertainty based on a bunch of features like use of modifiers. Okay, so deceivers, their hypothesis is that deceivers would express greater uncertainty and therefore use more modifiers. Okay, and the number of modifiers used is actually estimated using this toolkit MPQA, which is the multi-perspective question answering toolkit. And if you type it on Google, you get a ready reference to it. Then use of modal verbs. So deceivers would express greater uncertainty by using more modal verbs. Again, these are obtained from NPQA. Modal verbs could be like can, could, etc. Right? So deceivers would use more subjective language, which is more opinionated rather than being objective. Okay? So they use the opinion finder subjectivity lexicon to estimate the level of subjectivity in the tweets posted. by both the trolls and non-trolls. Quotations. So their hypothesis is that deceivers would use more quoted content because they are more uncertain about things, and therefore this is measured in terms of the number of quotations used. Questions. Deceivers would tend to use more questions, more interrogation, okay? And this is actually estimated by the number of question counts. And then there is this last interesting point, which is called hedges. So these are like words which lack commitment, okay? And there is a lexicon that they curate, which has these hedging cues, and they see how many of such hedge words are present in their data set, okay? For both the trolls and the non-trolls. Non-immediacy. So under this also they have various features which they measure, like self-reference. So deceivers would attempt to distance themselves from what they tweet, right? So they will not take ownership of a statement. So this can be measured. One way to measure this would be to count the number of first persons, okay? And then there could be group reference, which deceivers would actually tend to give more group reference, okay, compared to truthful senders. And this can be obtained using the LIWC toolkit. So we have already introduced ourselves to the LIWC toolkit earlier. So this gives you a lot of features which can be very handy. Then generalization. So more general narrative would be used for the highly deceptive users, and this can be again estimated using the MPQA. Then they would use more indefinite articles rather than definite articles. So like the use of the, etc. would be much less in their tweets, okay? This can be again estimated by the LIWC. So they would use more indefinite articles like a, and, etc. Then specificity. The different linguistic cues under specificity would be discourse markers like paragraph breaks, etc., etc. So liars would typically use less discourse markers so that, you know, things are jumbled up and they don't, so they have a less coherence, okay? So although their opinion gets transmitted, they make it sure that their opinion gets transmitted, but the discourse is not made very clear. It's hazy, actually. They would use less causation words, okay? This can again be estimated from LIWC. They would use less emotion, they would use more emotion words. So they would try to invoke emotion, as we have already seen. So this is a characteristic of, you know, the post-truth era. So people tend to actually invoke your opinion to generate your appeal for news material rather than stating facts. So this is what we already looked into, one of the striking characteristics of the post-truth era. Again, this can be estimated using the LIWC tool. Then sense terms. So they will be using less sensory details, okay? And they will be fabricating and more and more opinionated sentences, as this is also indicated by the extent of subjectivity, as we have looked into earlier. And this can be again estimated using LIWC. Now, mentions of numbers is commonly used as a marker of specificity, and they would typically avoid to use many number markers. So, and an easy way to find this out is to estimate the number of numbers that they use in their post, okay? So it's basically a number of quantities exactly that they use in their post, okay? Then relativity. So legitimate content would express more relativity. So they would actually try to relate or narrate factual incidents, okay? So that's why they would have more relativity content in them, because they are more grounded in the past literature or in the past observation, okay? And this, again, the number of relativity words can be counted using the LIWC tool. Information complexity, as I have already told you, that Higher sentence complexity results in lower perception of deception. Okay, so you measure this using the average word length, sentence length, and typically the authors look into words that are more than 6 letters, okay, and have a good number of punctuation. So if your sentence is typically complex, then you would imagine that there is less, deceptive content present. Okay, that's the hypothesis. Then information quantity. So deceivers typically would be hesitant in their words, and this hesitancy would be expressed in different ways by using, say, fewer words and sentences. Also, they use the usage of different part of speech like verbs, adverbs, nouns, prepositions, etc. would typically be different. I remember I told you about this idea of post-tag diversity. So more well-structured sentences will have a better diversity. Okay, that is what we have discussed earlier in one of the lectures. So similar ideas also can be borrowed here. So deceivers will have less interesting or less structured sentences compared to the legitimate users. Persuasion. So again, this can be some of the easy ways to measure them is the number of URLs used. Okay, so persuasive arguments would consistently use more URLs. Okay, more function words, then more examples. Okay, then use present focus. So this is commonly used in non-persuasive comments, and this can be measured again using the LIWC features. Then reward terms, the number of reward terms that are used. Okay, so they appear regularly in non-persuasive comments. So basically you get this, you get that, etc., etc. So types of rewards that you earn. So this kind of reward terms again can be estimated using the LIWC toolkit. And then you can count the number of hashtags. So they actually indicate are indicative of rumors. So this we have seen in our false rumor study also. So this is something that the authors also use as a clue to identify deceptive language markers. Morality, as I told you earlier also, so there is this moral foundation theory by Haidt and Garham in 2007, who define moral differences across different cultures actually. So moral foundations include care and harm, fairness and cheating, loyalty and betrayal, authority and subversion, purity and degradation. Okay, so these moral cues can be gathered, okay, using a lexicon, using a standard lexicon of moral cue words or cue phrases. And the authors hypothesize that deceptive tweets will have much less moral linguistic cues than the non-deceptive tweets. This is actually well understandable. Metadata. So again, this is easily understandable. They use the number of followers, number of followees, total tweet count, status count, number of retweets, etc. In the posts of both the trolls and non-trolls. And these they believe that they have a hypothesis that some of these features would be indicators of deceptiveness, and we will see how they are forming good indicators soon. So now coming to the results. So before we enter into the results, any clarification regarding the set of features? Quickly. If you have any clarifications. Any questions regarding the different types of features? Okay, so if there are no questions, we'll proceed with the results. So the authors first did a simple characterization, and then they used the ideas that they obtained from the characterization to build a machine learning model. So the first question that they asked, so remember this was one of their standing research questions when we started off with the research questions put forward in the paper. So they find out the top 10 meaningful words from the tweets of trolls and non-trolls. And what they find is some of the words are in fact indicative and show interesting clues. Like for instance, word like police, ethnic words like black, then words like killed, shooting, which are related to some sort of incidents, okay, that happened in and around 2016, and that could actually sow seeds of conflict, okay, which have actually potential to sow seeds of conflict. So this is, at least at the surface level, this is understandable from the use of the typical high frequent words. Okay. Now, this is an interesting plot. So here, the authors plot the different features, the features that are known to be positively correlated with deception. Okay, so these are positive deceptive linguistic markers known in the literature, and they try to estimate the fraction of each of these from their data for both trolls and non-trolls. So the troll data is represented in green, whereas the non-troll data is represented in pink. Okay, and what the authors plot here are the log mean scores. So they find the mean usage of a particular word or a particular category. Say for instance, modifier, the mean usage of modifier across the troll tweets, and compare it with the mean usage of modifiers across the non-troll tweets. Okay, and this is plotted as a distribution. So those bumpy things that you see there are the distributions. So the distribution of the log mean scores, and the log mean score values themselves are plotted on the x-axis. The y-axis contains the distribution of the log mean scores. Okay, and there are certain interesting things that the authors observe. So some of the known positive features that were actually also indicated in the current literature as being positively correlated with deceptive language and also found by the authors are the following. So this is what I mark in green and call them features supporting earlier hypothesis. So they find indeed more quotations and questions in trolls than non-trolls. They find more subjective language like use of opinionated words in trolls compared to non-trolls. They find use of fewer sense terms in trolls compared to non-trolls, and they find significant less use of moral cue words. So this was one of the things that the previous literature also indicated, that deceptive language would use actually much less use of moral terms. So the moral terms are indicated here by the features like authority vice, authority virtue, fairness vice, fairness virtue, harm vice, harm virtue, in-group vice, in-group virtue, morality general, purity vice, purity virtue. So these are all moral terms, and this has been curated using a lexicon. Okay, curated. This has been, so there is a lexicon curated, and the authors use this lexicon to estimate the number of moral keywords. However, they also find that some of the features which are known to be positively correlated with deceptive language do not indicate strong, significant results in their data. For instance, they find certain features to be contradicting with the earlier hypothesis, like the deceptive trolls would have less emotions, which is somebody, otherwise please mute. So please mute yourself. Okay, so some of the features that contradict earlier hypotheses are as follows. So the authors find that trolls have less emotive words. While previous literature said that trolls would have more number of emotive words, authors find the opposite. Authors also find less use of modifiers and modal verbs, less use of hedges, less use of generalization, and less use of indefinite articles. So at least in their data set, they find less use of these terms, while in the literature, it was indicated that these would be some of the positive markers for deceptive language. So the negative features, on the other hand, so these features were known to be negatively correlated with deceptive language, and all of them seem to hold for the author's data set. So they find that there is less self-reference, significantly fewer discourse markers, fewer causation words, fewer relativity words, less complex and shorter tweets, fewer nouns and verbs, less function words, less reward words, less present focus, more persuasive. Okay? So less present focus means that they are more persuasive, that it would indicate that they are more persuasive. And as you know, that deceptive language would try to be more persuasive. They want to actually impose their ideas on the normal public, okay, who are seeing their posts. So that's one of the primary objective of the trolls. Okay, so for the negative features, the authors interestingly find that all the features actually corroborate to what has been observed in the previous literature. Now they also do the analysis on the metadata. So what they observe is that, as we have also seen in case of rumors, the trolls use a much larger volume of hashtags. Okay, they use much larger number of retweets. Okay, however, their follower count is much lower than the non-trolls. Okay, they use much larger number of URLs. Okay, so which indicates that URLs are a way to persuade people. Okay, and they are so they have a slightly less, I would say, comparable following count. However, the status count is much more for the non-trolls than the trolls. So these are some of the interesting metadata features that they additionally observe in in addition to the deceptive language markers. Okay, so these are metadata features they also additionally use. So together, what we have learned so far: trolls are less certain, refer to themselves and others significantly less. They use significantly fewer discourse markers. They are less complex, shorter tweets, use less complex words with fewer than 6 letters, significantly fewer nouns, verbs, adverbs, and prepositions, use higher hashtags, tweets, and retweets, use highly persuasive linguistic cues, and show significantly fewer moral values. Okay? So these are some of the defining characteristics of the trolls as observed from the data collected by the authors. So now, from all this learning, the authors try to see if trolls could be actually identified using some machine learning model. Before we go there, is there any question regarding the results? If there is any question, you can place on the chat. No questions? We proceed. Okay. So the next question that the authors ask is that whether trolls can be identified. So they use all these deceptive markers that they introduced in the previous sections to train two classifiers. Okay. And they use a tenfold cross-validation. Okay. Cross-validation strategy. Now, as you have correctly noted earlier, that there is this huge data imbalance. Okay. So the troll class has much less number of users as well as much less number of tweets compared to the non-troll class. So that's the reason why the authors use the SMOTE tool. Okay, so SMOTE tool is a way to actually balance the data. So you oversample from the smaller class, okay, from the fewer class, and accordingly you do your so accordingly you balance the data and do your classification. Okay, so they use a proportion of 1 troll is to 5 non-troll. In reality it is much larger. Okay, however, this is what the authors assume, and based on this assumption they use 2 off-the-shelf machine learning algorithms, random forest and gradient boosting classifier, and they observe that for such a division of troll and non-troll and imbalance handler of SMOTE-NN, tenfold cross-validation gives an F1 score of 0.8 and an average recall of 0.8 for random forest, whereas gradient boosting gives an F1 score of 0.82 and an average recall of 0.88. So since you have the F1 score and recall, you can always compute the precision, so it's redundant. That's why the authors don't report that. Okay, so this is the observation that they have. So I would say that they do a pretty good job using the linguistic markers of deception in order to classify or identify automatically trolls from non-trolls. Of course, there is this 1:5 catch. One can use this as a hyperparameter and see, like, if you make it 1:6, 1:8, 1:9, or realistic to the ratio of the real Twitter users, troll versus non-troll, how does it matter? In case you have it, okay? How does this classification accuracy or performance change? So that's a task that one can take up. So the authors also go ahead to study the feature importance. So they see that the metadata features are the most important features. Okay, so among all the 8 features, the metadata features are the most important features. Okay, so on the x-axis there are the relative importances of the features, on the y-axis are the different features. Then comes persuasion, okay, like use of URLs, etc. Then comes information complexity, like shorter messages, lesser complex words and things like that. Information quality, like use of part of speech, etc. Then uncertainty, morality, specificity, and non-immediacy. Non-immediacy. So these are the rank of the different feature categories. They do a even further fine-grained analysis, and this is what they find, like hashtag count, number of retweets, usage of noun, average length, total tweet count, status count, URL count, followers, 6-letter usage, self-reference, hedges. These are some of the classificatory factors. Causation. These are some of the good classificatory factors for discriminating the trolls from the non-trolls. Okay, for distinguishing the trolls from the non-trolls. So these are some of the good predictive features that actually are helpful in classifying trolls from the non-trolls. Okay. In addition, the authors do something interesting. So they try to plot partial dependence plots. So these plots actually are generally done to make the machine learning model more interpretable. So you want to have more interpretable observations, or you want to explain which features, or like the intensity of a particular feature, how does it affect the classifier performance, right? So these are like tools that are used in studying explainable and interpretable machine learning. So that is the next set of lectures that we are going to do in the next few classes, where we will study explainable and interpretable machine learning. So this is just a starter for it. So partial dependence plots are one of the ways in which you try to make your machine learning model a little more interpretable. So what they study here is they try to see some of the effect of some of the features, okay, some of the specific features, and they marginalize all the other features, okay, so that they understand the specific importance of this particular feature. Okay, so partial dependence plots actually marginalize. So say you have one feature X, for instance, in this plot you see, in the left plot you see retweets, hashtag count, total retweet count. So let us take retweets. Okay, so you take retweets and you marginalize all the other features against retweets, okay, to see what is the predictive power of retweets only. Okay, so you suppress all the other features and try to see what is the effect of retweets only. And what you observe is that on the x-axis you try to plot the probability of the use of retweets, okay, also probability of hashtag count, the use of the increase of hashtag count, or the total retweet count. Okay, so you plot this on the x-axis, and on the y-axis you look at the dependence of the output on this particular variable. Okay, so and you see that as the likelihood rises after a point, say for instance 0.6, etc., what happens is that usage of these features actually are strongly predictive of the troll-like behavior. Okay, so if these features are, the likelihood of use of these features like retweets, hashtags, total tweet count, okay, as this increases and crosses a particular count or number, like say 0.6 in this case, the predictive power of these features actually gets manifold. Okay, and they are highly predictive of the troll-like behavior. Okay, similarly on the right hand side we show the number of nouns, word count, and average tweet count. Okay, so here the trend is opposite. So as we have seen that trolls are negatively correlated with use of nouns, the number of words, and the average tweet length. That's why the less likelihood of using them actually is highly predictive, okay, of troll-like behavior. Okay, so that's why you see a peak at the beginning. So the x-axis is kind of likelihood of usage. So in the beginning, where you have less likelihood of usage of this kind of markers, you see a high predictive power. As you have a higher increase of likelihood, okay, this predictive power decreases. So they are more and more non-troll as you go far from zero. Okay, so from this paper, the summary of findings is as follows. So the authors tried to do this deceptive language analysis, and they also were able to predict with pretty good performance what is a troll from what is a non-troll, and making such predictions is effective. Actually, they obtain a pretty good performance, and also they show what are the most important features and they also try to explain their model by showing the effectiveness and the predictive power of certain specific features. So we have less than a minute left. If you have some questions, please feel free to ask. Otherwise, you can also email me the questions. So from tomorrow, we will start explainability in machine learning.